Welcome to this revision series of the November 2019 Science Paper 2. We have reached the revision of question B4, and question B4 reads, both barium carbonate and barium sulfate are insoluble in water. Both barium carbonate and barium sulfate are insoluble in water. A. Choose a substance from the following list to fill in the blank spaces for the preparation of barium sulfate. Choose a substance from the following list to fill in the blank spaces for the preparation of barium sulfate. Now, the list contains sulfuric acid, nitric acid, lead-2 sulfate, magnesium sulfate. Sulfuric acid, nitric acid, lead-2 sulfate, magnesium sulfate. So we've got all these things, and let's now look at the paragraph where the blank spaces are. Barium carbonate is added in excess to a solution of dilute blank. The excess barium carbonate is filtered off to collect a suitable filtrate. The filtrate is then added to a solution of blank to produce barium sulfate, which is filtered off from the product mixture. We go through that again. Barium carbonate is added in excess to a solution of dilute blank. The excess barium carbonate is filtered off to collect a suitable filtrate. The filtrate is then added to a solution of blank to produce barium sulfate, which is filtered off from the product mixture. Now, we are supposed to fill in these two blanks. Now, the first blank, we have barium carbonate is added to in excess to a solution of dilute. Now, here, what we are creating, we have a carbonate which we know is insoluble, and we are creating a soluble salt from a carbonate. Now, this salt is a barium salt which is soluble. Now, to guide us, we know that all nitrates are soluble. So be it barium nitrate should be soluble. So we are going to add barium carbonate to nitric acid. The reason is simple. We want to create barium nitrate from barium carbonate. We cannot add barium carbonate to sulfuric acid because barium sulfate is insoluble and it is what we are preparing, and this is not the time when we should actually prepare barium sulfate directly. So the first blank will be nitric acid. So it will read, barium carbonate is added in excess to a solution of dilute nitric acid. After that is done, we actually now have barium nitrate. Okay? Barium nitrate. Barium nitrate is soluble, so it is in aqueous state. The excess barium carbonate is filtered off to collect a suitable filtrate. The filtrate is then added to a solution of. So the filtrate contains barium nitrate, which is a soluble salt. Now, from barium nitrate, we need to make barium sulfate, which is an insoluble salt. So we need to look for another soluble salt to mix the barium nitrate with to give us barium sulfate. So we need a sulfate, a soluble sulfate. So from the list, we have sulfuric acid, we've got nitric acid, we've got lead-2 sulfate, we've got magnesium sulfate. So 2 from the list are acids, 2 are salts. But lead-2 sulfate is insoluble, while magnesium sulfate is soluble. So we are going to use magnesium sulfate instead of lead-2 sulfate. So we're going to add magnesium sulfate. Now it will read, barium carbonate is added in excess to a solution of dilute nitric acid. The excess barium carbonate is filtered off to collect a suitable filtrate. The filtrate is then added to a solution of magnesium sulfate to produce barium sulfate, which is filtered off from the product mixture. Now we understand that when barium nitrate reacts with magnesium sulfate, the end product will be barium sulfate and magnesium nitrate. So these will be the two end products. Where magnesium nitrate is soluble, barium nitrate isn't soluble. Let us go to B. B1. B1 reads, what type of reaction is used to prepare barium sulfate? There is only one type of reaction that is used to prepare insoluble salt, and that is the precipitation reaction. Precipitation reaction. So this is a precipitation reaction. We go to B2. B2 is saying construct a balanced equation for the reaction that produces barium sulfate in this particular case. Construct a balanced equation for the reaction that produces barium sulfate in this particular case. Now, here we have it. We have barium nitrate reacting with magnesium sulfate. So we have the two reactants. So we have barium nitrate plus magnesium sulfate to give us barium sulfate plus magnesium nitrate. Now, they said balanced. If we check, we have one barium on both sides. We have one magnesium on both sides. We've got two nitrogens on both sides. And we've got 10 oxygens on both sides. This brings us to the end of question B4. Remember, like I always say, if you like the video, give me a thumbs up. And if you've not yet subscribed, subscribe to the channel. Thank you very much. We meet next time when we look at question B5.